In previous slides, we have studied the result, that is cos A plus B, and then we have defined the values of cos pi by 2 plus theta and cos pi by 2 minus theta, isn't it? Now, in this lecture, we will see the results for sine A plus B and sine A minus B. Now, for that purpose, see here theorem 3, for any two angles, A and B, sine A minus B is equal to sine A cos B, okay, sine A cos B minus cos A sine B. Now see there, if you remember that the previous results, in case of cos, we have the result to the RHS cos sin. But here we have mixed terminologies, sin cos sin. Okay, do not change this order, because if the thetas are positive, then doesn't matter, then value does not get affected. But thetas are negative, if thetas are negative, then values get affected. So don't change this order. Try to remember in given manner, sine A minus B. Now in case of sine, the sign between A and B is also negative, and sign between these two terms is also negative. That is, sign to both the sides, LHS and RHS, is same. Okay. Now, how can we prove this result? So, to prove this result, we use the previous result. Now, we know that cos pi by 2 minus theta is equal to sin theta, isn't it? Therefore, here putting theta is equal to A minus B. Now, we can prove the result in the cos pi by 2 minus theta, that is theta is equal to A minus B. Therefore, here cos pi by 2 minus theta, and theta, we write theta as pi by 2 minus A minus B, because we have chosen it. Now this is of the form A minus B, okay, or x minus y. Then we know that is equal to what? Cos A minus B is equal to cos A, that is cos pi by 2, and this theta can be written as cos pi by 2 minus A for convenient, and here this minus becomes plus B. Now this is of the form, this is one theta and this is another angle. So let us see, this is x and this is y. Therefore is equal to cos pi by 2 minus A into cos B minus, because there a plus sign, therefore we will have here negative sign, because this is the result for cos 1, and here sin A sin B, that is sin pi by 2 minus A into sin B. Therefore, again, now what is its result? Cos pi by 2 minus theta. We have just seen it. Cos pi by 2 minus theta is equal to sin theta, that is sin A, because cos reduces to sin. I have just told you. Cos reduces to sin. Therefore, here we have sin A into cos B as it is, minus to the next side, here sin pi by 2 minus theta reduces to what? Sin pi by 2 minus theta reduces to cos theta, and sin theta as it is, but here theta is what? Theta is nothing but a, that is here cos a into sin b. Okay, here therefore we get our required result, that is sin a minus b is equal to sin a cos b minus cos a sin b. Our result get proved, and you can see there sin cos sin, and if we have negative sign to the LHS, then again we have negative sign to the RHS also. And by using this result here, we can write that sin pi by 2 minus theta is equal to cos theta. Okay, sin pi by 2 minus cos theta, sorry, sin pi by 2 minus theta is equal to cos theta. We used these two results, cos pi by 2 minus theta is equal to sin theta, and sin pi by 2 minus theta is equal to cos theta. Okay, now here the next theorem, that is fourth theorem, is that for any two angles A and B, sin A plus B is equal to sin A cos B plus cos A sin B. Now it is given that verify it. So let us try to verify it. Here we can verify this theorem. It is very easy to verify by using the above result. Here sin A plus b, you can prove in both the ways. Okay, that is by using result of cos or by using the previous result also. So sin a plus b can be written as sin a minus b, then this minus become again plus. Okay, now let us see is equal to sin a, okay, this one sin a minus b. So sin this one theta and this is another theta. Now sin a minus b is equal to, from the above result, sin a into cos minus b. Okay, again we have a negative sign there, and here cos a into sin minus b, or is equal to sin a does not changes, it is remains as it is, but cos minus theta is equal to what? Cos theta, that is cos b, and minus cos a, and what about sin minus theta? Minus sin theta minus sin b, therefore is equal to, here we can write that sin a into cos b, and this negative sign and this negative sign, there is product, therefore minus become plus, and we can write cos a into sin b. That is, here we can conclude that sin a plus b is equal to sin a cos b plus cos a sin b. That is, order of the theta remains same, but we have the combination sin cos and cos sin. It is very easy to remember. Okay, if you recite it, then you will get that. Okay, so try to remember this one and try to prove these results your own way also, then you will understand it thoroughly. So we have proved these four results. Okay, And by using these results, you can prove the next result. Which result is there? That is, if you remember that we have seen cos pi by 2 plus theta is equal to cos theta. So how we can prove it? Now let us see, a is equal to pi by 2 and b is equal to theta. Therefore, sine pi by 2 plus theta is equal to sine a into cos b plus cos a into sine b. But sine pi by 2 means 90 degree, that is 1 into cos b plus, means b means here actually b is theta. Okay, b is theta. So substituting the value of b, cos pi by 2 means cos 90 degree, and cos 90 degree is equal to what? 0 into sin theta. That is, finally we have what? 1 into cos theta, 0 into sin theta, 0. That is equal to eventually cos theta. Means what? Finally we get the result that sin pi by 2 plus theta is equal to cos theta. So remember that if we add theta in pi by 2 or subtract from pi by 2, then sine reduces to cos and cos reduces to sine. Only we have to look at the sign, that is either it is positive or negative according to its position. Now sine, this pi by 2 plus theta lies in second quadrant, but in second quadrant sine ratio has positive sign, that's why it is a positive cos theta, isn't it? Now try to solve some examples using the above results. So in exercise, one question is given there. Find the values of, first, sine 15 degree. Now you will think that sine 15 degree, how we can find out its value? 15 degree is not a standard value, standard theta. So this is the matter, that is how we will solve it. Now consider the given value, that is sine 15 degree function. Sine 15 degree we have to convert into two standard angles, as if we see this one, then it is the subtraction of two standard angles, that is sine 45 degree minus 30 degree, isn't it? Now this one can be compared with sine A minus B. And what is the result for sine A minus B? You know that one, that is sine A, but here A is equal to what? Sine 45 degree into cos B, that is 30 degree, minus remains minus now cos A, that is first angle, into sine B, that is second angle. Okay, and here for understanding purpose you can give the reference of the theorem also, that is sine A minus B is equal to sine A cos B minus cos A sine B. Okay, and you can use these references, it gives you a good representation also. Okay, so there is no matter that is you are providing these results or not, but if you provide it, then it will be better for you. Now let us come to the same point. Sine 45 degree, what is its value? Root 2, 1 by root 2. And cos 30 degree, what is its value? Cos 30 degree is equal to, cos 30 degree is equal to root 3 by 2 minus cos 45 degree. Cos 45 and sin 45 value, that is 1 by root 2. Again sine 30 degree, half. Okay. You should know all these values. In last lecture I have also told you, try to remember all these values. Okay. Without these values you can't solve, or you are not able to solve any example. Okay. So it is very essential. Now root 3 denominator is 2 root 2 minus 1 into 1 1 and into 2 root 2. That is, here denominator is same. Therefore, we can collect the terms at the numerator, root 3 minus 1 by 2 root 2. Here, in this way, we can solve the examples by using the formulas which we have seen. So here, we can solve one more example, that is, let us see cot of, okay, we will see later about cot 1, because if we prove the result of tan theta, then we will prove it. Here cos 75 degree, you can take sin 75 degree also, no matter. Okay, cos 75 degree is equal to this term. Again reduce cos 75 degree into two standard angles as cos 45 degree plus 30 degree. Okay, what is its sum? Its sum is nothing but 75 degree. Okay, you can do this one, verify this one. So cos 45 degree plus 30 degree, that is cos A plus B. And what is the formula for cos A plus B? Cos A cos B minus sin A sin B, that is cos 45 degree into cos 30 degree minus sin 45 degree into sin 30 degree is equal to, what is cos 45 degree? 1 by root 2. Cos 30 degree, half. Sin 45 degree, sorry, cos 30 degree is how much? Root 3 by 2. And sin 45 degree, 1 by root 2. And sin 30 degree, half. Okay. And if there is plus sign, okay, in cos, then we will have a negative sign in result. Now again 1 into root 3, 2 root 2 minus 1 by 2 root 2. That is, denominator is same, 2 root 2. Therefore, cos 75 degree is equal to 2 root 2. In this way, we can prove the results. Now, if we want to prove one more result, here let us have one more example there. We can take one more example. Root 2 cos pi by 4 minus a is equal to cos a plus sin a. Now this is the example. Here we have to prove this one. That is, if we consider the either LHS, then we have to prove is equal to RHS, and if we consider RHS, then we have to prove the is equal to LHS. So let us have LHS is equal to root 2 into cos pi by 4 minus a. So root 2 as it is in square bracket cos pi by 4 minus a by using a minus b. So cos a minus b, cos a cos b minus become plus sin a into sin b, isn't it? So root 2 again as it is, but cos, sorry, here pi by 4 is there, cos pi by 4 is 1 by root 2 into cos a plus Sine pi by 4 again have same value 1 by root 2 into sine A. Now multiply the terms inside the bracket by this root 2. Therefore is equal to this root 2 get cancelled, we get only cos A plus again this root 2 get cancelled and we get here sine A. And what is this? This is our required RHS. Therefore is equal to, we can write that RHS cos A plus sine A. Now we will see the next results in next lecture.